Quick, switch on your cam. Okay, Pranjal. Quick, everyone switch on your cam. Okay, now listen. I'll start putting people in waiting room. Without cam, okay, just get out of it.
So 1 second.
Okay, I'm seeing the message. Okay, Mansi's birthday. Okay, happy birthday, Mansi. Okay, now what you can see on your screen is a transformer. Now listen to me. There are two important points of a transformer. One is transformer works on the principle of mutual induction. Transformer works on the principle of dash. Answer is mutual induction. In fact, if you see the diagram of a transformer, just see the diagram. This is primary, this is secondary. Doesn't it look like a diagram of mutual induction? Just check. Doesn't it look like a diagram of mutual induction? And second point is transformer works only on alternating current. Transformer works only on alternating current. It doesn't work on direct current. Is it clear? These two are the points. I've not started the topic, but these two are the points you should know for a transformer. These two are the points you should know for a transformer. What is the first point? That it works on the principle of mutual induction. And secondly, transformer works only on alternating current. Transformer works only on alternating current. Okay, now listen. Look at the diagram of a transformer. Everyone, please look at the diagram of a transformer. On your screen is the diagram. Now, before that, what is a transformer? Very easy topic. Listen to me. Transformer, as the name says, it will transform. What it will transform? Input voltage. So listen. What is the meaning of transform? Can I say change? The meaning of transform is change. How can you change? For example, if people tell you, you have changed. So first you should tell them, I have not changed, I have transformed. Now, can I say you can change for the better or you can change for the worse? Means you can have a positive change in your life or you can have a negative change. Okay. So for example, let me tell you, if you got 60 marks in your exam and in the next exam, you got 70 or you got 50. Can I say in both cases you have transformed your marks? I'll repeat. In the first exam, you got 60. in the second exam, even if you get 70 or if you get 50, can I say you have transformed your marks? If you get 70, you have transformed your marks for the better. If you get 50, you have transformed your marks for the worse, but you have transformed your marks. So either you have made your marks better or you have made your marks worse, but you have changed your marks. Similarly, what does transformer do? Listen to me. Transformer either increases or decreases input voltage. Okay? It does not convert AC to DC, DC to AC, nothing like that. If I give you some voltage, okay, Sejal, if I give some voltage, if it increases or if it decreases that voltage, then it is called as transformer. So what does transformer do? Transformer changes the input voltage. So the output voltage will either be greater or lesser than your input voltage. Is it clear? Now, if the output voltage is higher than the input voltage, we call that transformer step-up transformer. If the output voltage is higher than the input voltage, we call that transformer step-up transformer. And if the output voltage is lower than the input voltage, then we call that transformer step-down transformer. Then we call that transformer step-down transformer. Okay, so what does a transformer do? Tell me. A transformer transforms input voltage. That means your output voltage will either be greater than input voltage or it will be lesser than input voltage. That is what transformer will do. Transformer will transform the voltage. So if the voltage becomes greater than the input, it is called step-up transformer. And if the voltage becomes lesser, it is called as step-down transformer. Okay, it is like stock market transforms your money. Stock market transforms your money. Now, either your money can increase or your money can decrease. Can I say in both cases your money is transformed? So if you put in the money, if you put the money in the stock market and if it increases, it is called a step-up market. And if you put your money in the stock market and if your money decreases, it is called a step-down market. Can I say in both the cases, your money is transformed? Either it has increased or it has decreased. Now, if you don't want to change your money, then you don't put your money in the stock market, correct? If you want the money as it is, then you don't put the money. Similarly, if you don't want the voltage to be changed, then you don't need a transformer. That means if a transformer neither increases nor decreases the input voltage, then I don't need a transformer. If you don't want to change your voltage, then you don't need a transformer. You need a transformer only when you need to change the voltage, either increase or decrease. And what I'm talking about is only alternating current. Transformer does not work on direct current. Transformer works only on alternating current. Okay, this is the logic. So let me give you a quick recap. So tell me, what is a transformer? Transformer will transform. What it will transform? Input voltage. That means either it will give you higher voltage or it will give you lower voltage. In both the cases, it has transformed your voltage. Now, if it increases the input voltage, it is called a step-up transformer. And if it decreases the input voltage, it is called a step-down transformer. Okay. What is the principle of a transformer? It works on the principle of mutual induction. And transformer works only on alternating current. So do one thing, write down the side heading transformers. Right now. Below transformers, write down transformer is a device which transforms the input voltage. Transformer is a device which transforms the input voltage. Transformer is a device which transforms the input voltage. Full stop. Below that, right? Next one, right down. It works only on alternating current. It works only on alternating current. It works only on alternating current. Full stop. Next side heading you write down principle. 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 Below that write down. It works on the principle of mutual induction. It works on the principle of mutual induction. It works on the principle of mutual induction. Now look at the screen. Let me explain the diagram. Then you need to draw the diagram. So look at the diagram. See this. It is same like mutual induction. This is one coil which I call primary coil because it is connected to the power source. This is called as secondary coil. And they're separated by a core. Correct, Sejal? They're separated by a core. Since this topic is what? What is the name of the chapter? EMI, correct? Electromagnetic induction. Now, in induction, the two coils cannot touch each other because if they touch each other, it becomes conduction. Induction means you should not touch each other and transfer the charge. Therefore, it is very important that primary and secondary are separated by some distance. That is why I separate them by something called as core. So look at this. This is my primary coil. This is my secondary coil. How do I differentiate between primary coil and secondary coil? The coil that is connected to power supply is called primary coil. And the coil which is not connected to a power supply is called as secondary coil. And between the primary coil and secondary coil, I have something called as core, which separates the primary coil and secondary coil. And primary coil is called as input coil. And secondary coil is called as output coil. Okay, because primary coil is called input coil because it is connected to the power source. Therefore, primary coil is called input coil and secondary coil is called as output coil. Don't write, I'll give you time to write. All of you look at the screen first. Now, total number of turns in the primary is called NP. What does NP mean? Total number of turns in the primary. And over here, total number of turns in the secondary is NS. Therefore, total number of turns in the secondary will be NS. Therefore, tell me, did you understand this diagram? Primary, secondary, core. Primary is called input coil. Secondary is called output coil. And number of turns in the primary is NP. Number of turns in the secondary is NS. Till here, everyone understood? Now, let the total flux in the coil be phi. Let the total flux in the coil be phi. Let the total flux in the coil be phi. Therefore, total flux of the primary coil will be number of turns in the primary into total flux, and total flux in the secondary will be Ns into phi. Look at the screen. Total flux of the entire system is phi. Therefore, total flux of the primary will be number of turns in the primary into total flux. Similarly, total flux in the secondary will be number of turns in the secondary into total flux. Now, this whole thing becomes one diagram. Okay, this whole thing becomes one diagram. Therefore, you have written the principle. It works on the principle of mutual induction. Okay, below that write down side heading diagram. Below that write down side heading diagram and draw this particular setup. Draw this particular setup. Start.
So core is a imaginary line or what? Imaginary space or what?
What core?
Yes, yes.
No, core is actually there. Core is actually there. If you want, this is actually core. Like this. Core is like this in between. This is the actual diagram of a transformer. So primary and secondary are separated by an iron core like this. So it is not imaginary. It is actually there. But in the diagram, those two lines represent the core. It is actually there. Means the two lines are not there, but there is a core which is separating them. Okay, this is just a representation.
Okay.
Yeah, everything on the page. Then we. Once you're done, just put a dot. So you have done the principle, you have done the diagram. Okay. Now look at the construction. Okay. Now look at the construction, Veronica. Look at the construction. Now the construction is very simple. See what is written. It consists of two coils, primary and secondary, insulated from each other, means separated from each other, and wound on a soft iron core as shown in the figure. Primary coil is called input coil and the secondary coil is called as output coil. Did you understand what is written? Let me repeat. It consists of two coils, primary and secondary, separated from each other by a soft iron core. Primary coil is called input coil and secondary coil is called as output coil. So below the diagram, write on side heading construction and write this paragraph. Start. So now you should know the principle, you should know the diagram, you should know the construction, you should know the definition. Now, look at Lenz law topic in your notebook and see the formula for Lenz law. Check. What is the formula for Lenz law? Check and let me know whether you got it. Just reply yes or no. Aditi, I saw your message now. I hope you have understood what I was saying. Look at Lenz law and tell me whether you got the. See, this is Lenz law, what I'm writing on the screen. Tell me, are you getting this? This is the formula for Lenz law. E is equal to minus d phi by dt. Now, look at the main derivation of a transformer. Please look at this. I'll keep this over here and I will keep doing it next to it other as well. Now see here, we know from Lenz law that, look at this, we know from Lenz law that E is equal to minus d phi by dt, correct? We know that this is from Lenz law. Everyone first look at the screen, then you can take time to write. Now just listen, don't write anything. Now if I apply this particular law to the primary coil, so will it not be EMF of a primary coil is equal to minus d by dt of flux of the primary coil? If I apply Lenz law to the primary coil, will not I get P as my suffix? Or can I say EP is equal to minus d by dt? Do I have a formula for flux of primary? Check the diagram. Do I have a formula for flux of primary? Yes. What is the formula for flux of primary? Total number of turns in the primary into overall flux, correct? Or can I say total EMF of primary is equal to minus NP, I will take it outside. Minus was anyway outside. Number of turns is constant, so I take it outside. Minus NP d phi by dt. Now this is the same thing that they have done here. Check. From Lenz law, E is equal to minus d phi by dt. If I apply that law to the primary coil, I get EP is equal to minus d phi p by dt. And instead of phi p, can I write NP into phi? Therefore, NP I can take it out. Therefore, I get EP is equal to minus NP d phi by dt. Similarly, if I apply Lenz law to the secondary coil, I will get ES is equal to minus d phi s by dt, or ES is equal to minus d by dt. Okay. Now we will apply the Lenz law in the secondary coil. Now tell me, if I apply Lenz law in the secondary coil, what should be my answer? I will get ES is equal to minus d by dt of phi s, because now it becomes secondary. Now tell me, do I know the formula for secondary flux? Minus d by dt. Instead of phi s, can I write ns into phi? Because number of turns in the secondary into phi. Or ES is equal to minus ns d phi by dt. Can I write this? Therefore, can I say EP is equal to minus NP d phi by dt and ES is equal to minus NS d phi by dt. Now, if I divide 1 and 2, that is ES upon EP, tell me what will be my final answer. If I divide ES and EP, let me show you. What is ES? Tell me, what is ES formula? ES is equal to minus NS d phi by dt upon EP. EP will be minus NP d phi by dt. So when I say d phi by dt and d phi by dt will cancel. Minus and minus will cancel. Therefore, you have ES by EP is equal to NS by NP. Did you understand the derivation on this page? This is one of the answers for your transformers. This is one of your answers for your transformers. Now I'll show this page. Now, if I apply Lenz law to the primary coil, I will get EP is equal to minus NP d phi by dt. Or ES is equal to minus NP d phi by dt. Now, if I apply Lenz law to the secondary coil, I will get EP is equal to minus d by dt. Or ES is equal to minus d by dt. Can I write this? Yes. Or can I say EP is equal to minus NP d phi by dt? Or ES is equal to minus d by dt. Can I write this? Now I'll show this page. And this is one of the most important equation of transformer. Okay. But tell me, did you understand from here, from Lenz's law? This is the basic formula. This formula I apply to the primary coil, I get this answer. The same formula I apply to the secondary coil, I get this answer. If I divide ES by EP, I get NS by NP. Tell me, are you all understanding what is written on the screen? Therefore, will. Okay. If you have any doubt, please ask. I want you to do it without seeing. So you have written construction. Below that, write down side heading working. Below that, write down side heading working and write this derivation. Everyone, quick. Finish writing. Write how I have only written, and then put a dot once you come to the final step. Now, if you notice the formula, see here. Okay, everyone look at the screen now. Now, in this formula, ES by EP is equal to NS by NP. In this formula, NS by NP is called as turns ratio or transformer ratio. Why it is called turns ratio? Because it is a ratio. Ratio means it has a division sign, yes. And can I say both numerator and denominator are talking about number of turns. Numerator is talking about number of turns in the secondary and denominator is talking about number of turns in the primary. That is why this particular quantity is called as turns ratio or transformer ratio. You can make a note. This particular quantity is called as turns ratio or transformer ratio. Written? And this is one of the important formula, that is ES by EP is equal to NS by NP. Okay, important formula. That is ES by EP is equal to NS by NP. Now, look at this. If I take an ideal transformer, there is no power loss. Okay, everyone please listen to me. If I take an ideal transformer, there is no power loss. What is the meaning of no power loss? My input power is same as output power. Are you listening? For an ideal transformer, input power input power is equal to output power. Now, what is the formula for input power and what is the formula for output power? For that, we need to go to 11th standard. Remember 11th standard in current electricity, what was the formula for power? Voltage into current. Do you remember? Basic formula for power in a electrical circuit is voltage into current. Do you remember that formula? P equal to VI. Basic formula for power in electronic circuit is voltage into current. Therefore, can I say if the general formula for power is voltage into current, that is E into I. The general formula for power is voltage into current, that is E into I. So can I say input power will be power of primary and output power will be power of secondary? Do you agree? Because input coil is called primary coil and output coil is called secondary coil. This is the general formula for power. Therefore, can I say input power? Can I say input power will be power of the primary coil? And what is the formula for power of the primary coil? It will be EP into IP because it will be voltage of the primary into current of the primary. That is what is written here. Just check. Input power is EP into IP. Now, what is output power? Now, output power is power of the secondary, correct? Output power is power of the secondary. And what is the formula for power of the secondary? ES into IS. Just check. Output power is ES into IS. And since input power should be same as output power, I can equate EP/IP is equal to ES into IS. Therefore, I get ES by EP is equal to IP by IS. Clear? Did you understand? Okay. Now, again, I'll explain on a blank page the same concept. Now, please look at the screen. Tell me, for an ideal transformer, can I say input power should be equal to output power? Now, input power is nothing but power of primary and output power is nothing but power of secondary. And what is the general formula for power? Voltage into current, that is E into I. Therefore, can I say power of the primary is E of primary into I of primary is equal to E of secondary into I of secondary. Correct? Therefore, I get EP is equal to ESIS. Therefore, can I say ES by EP is equal to IP by IS? ES by EP is equal to IP by IS. Till here, did you understand? But from your previous derivation, what was ES by EP? Can anyone tell me? From your previous derivation, what
NS
was
upon NP.
NS upon NP.
NS upon NP? Therefore, can I say this is my complete transformer equation? Just check. Now you look at what is written on the screen and tell me if you're understanding the complete transformer equation, where 16.5 is your final answer. 16.5 is this. This is your final transformer equation. Now read it and tell me if you have understood. Same thing. Listen to this. For an ideal transformer, input power is equal to output power. Input power is EPIP. Output power is ES into IS. I get ES by EP is equal to IP by IS. But we know from the previous derivation, ES by EP is equal to NS by NP. Therefore, I can directly write this equation. ES by EP is equal to NS by NP is equal to IP by IS. This completes the derivation of a transformer. Easy. Therefore, start writing below that equation itself for an ideal transformer and start. What happened, Pranjal? How did you fall? Pranjal, can you hear me? Cannot hear
Yes, sir. Yes, sir.
you. How did you fall?
Yes, sir.
Still cannot hear you.
Sir, I'd fallen.
Message. Now, right under that, types of transformers. Right now. Types of transformers. Right now. First type, step up transformer. And the second one is step down transformer. Okay. Two fractures. Step up transformer and step down transformer. So write down step up transformer. Tell me what happens in step up transformer. Output voltage increases or secondary voltage increases. Right? In step up transformer, the output voltage or the voltage of the secondary is greater than the primary. In step up transformer, output voltage, that is voltage of the secondary, is greater than that of the primary.
Can you please repeat, sir?
In step up transformer, the output voltage is higher. That means voltage of the secondary is greater than voltage of the primary. Below that, write down step down transformer. Can you write on your step down? Exactly opposite. In this, the output voltage is lesser. That means voltage of secondary is lesser than voltage of primary. In step down transformer. This is how actually a transformer looks. If you want, you can draw this diagram. This is how a transformer looks. Primary coil, then you have an iron core, and then you have a secondary coil. Primary coil, then you have an iron core in between, which is separating primary and secondary, and then you have a secondary coil.
So why the secondary coil is more wounded around iron core?
Now again, I could not understand why.
So means that primary coil is less wounded now on iron core and secondary coil is more.
Number of
So,
turns you're saying.
Why? Yes, sir.
That can be anyway. This is a step-up transformer actually. In step-up transformer, number of turns in the secondary are more. You can make number of turns more in the primary also, but it cannot be equal. Either
So
it can
what
be
happens
step-up.
if the turns will be equal?
Then there is no need of a transformer. Then if turns are equal, then can I say NS and NP is same? Then can I say NS by NP is same? I'll tell you what happens if turns are equal. Please look at the screen. Everyone look at the screen. We have the equation of a transformer, which is ES by EP is equal to NS by NP. Everyone knows this equation of a transformer. Now, if number of turns are equal, can I say NS and NP are same? Therefore, can I say it cancels and it becomes equal to 1? Therefore, can I say ES equal to EP? Then can I say voltage of the secondary is same as voltage of the primary? That means my voltage has not changed. Then if my voltage has not changed, there is no need of a transformer at all. Why do I use a transformer? I use a transformer to change the voltage. Now, if I don't want to change the voltage itself, then I don't need to use a transformer. So number of turns cannot be same in both. It has to be different. Okay. Either more in primary or more in secondary. Okay. Okay. Now, from your module, come to page number 20 in your module. In EMI module, come to page number 20 in your module. That is your module 8. In that, can you see one side heading, AC generator or dynamo? Can you see that side heading? AC generator or dynamo?
So, Now listen, you don't have to study this in detail like how you have studied transformer. You don't need to study this in detail. You just have to know a few points. Listen to this. First one is AC generator is also called as only generator, or it is also called as dynamo. Okay, these are the names of AC generator. AC generator is also called as generator, or it is called as a dynamo. Okay. Now, the first point you need to remember in this session is, look at the first point.
An electrical machine used to convert mechanical energy into electrical energy is known as AC generator. That is the first thing you need to understand. So dynamo converts mechanical energy into electrical energy. So first point, write down in your notebook. What does the dynamo do? It is there in your module also, page number 20. An electrical machine used to convert mechanical energy into electrical energy. It is an electrical machine used to convert mechanical energy into electrical energy. Second point. Second point. It works on the principle of electromagnetic induction. Right on. Second point. It works on the principle of electromagnetic induction. It works on the principle of electromagnetic induction. Third point, the maximum EMF generated by AC generator is, write down the formula, NAB omega or NBA omega, however you want, you can write it. The maximum EMF generated is E naught is equal to NAB omega. Where, look at this, this is E naught is maximum EMF, where E naught is maximum EMF, N is number of turns, A is area, B is magnetic field, and omega, I hope you know the formula for omega. Omega is 2 pi f or 2 pi by t, angular frequency. Omega is 2 pi f or 2 pi by t. Omega is 2 pi f or 2 pi by t. This formula becomes very important for your AC generator. That is the maximum EMF. Therefore, for EM, that is your AC generator dynamo, these are the only points you need to remember. Unlike transformer, for AC generator, these are the only points you need to remember. So read the points for AC generator again. So what are the names for AC generator? AC generator or dynamo or only generator. It converts mechanical energy into electrical energy. It works on the principle of electromagnetic induction. And the maximum EMF is given as E naught is equal to NAB omega, where N is number of turns, A is area, B is magnetic field, and omega is angular frequency, which is 2 pi f. Omega is angular frequency, which is 2 pi f. Okay. Now, based on transformer and this, we will do some amount of problems. Okay. Come to the page number 29. Come to the page number 29, all of you. So on page number 29, can you see the side heading application of EMI? That is dynamo and transformer and all that. See question number 1 and tell me what should be the answer for question number 1. Start solving and tell me what should be the answer for question number 1.
C. Generator.
Answer will be
C.
generator. Correct. Therefore, which of the following is constructed on the principle of electromagnetic induction? Answer is AC generator or only generator. Therefore, answer for the first one is C. Got it? Now, second, tell me what should be the answer for question number 2? Then be correct. Others try to answer. First of all, it does not convert anything into anything. Unlike dynamo, transformer does not convert anything to anything. Therefore, answer B and answer D is out. And also, I know transformer works only on AC. Therefore, option A is also out. Therefore, I'm left with option C, where a transformer is employed to obtain a suitable AC voltage. Is it clear? Therefore, answer for the second one is C. Answer for the second one is C. So answer for the first one is also C. Answer for the second one is also C. Now, try to answer the third one. Start. Try to answer the third question. Melita, correct. Others try to answer.
C.
Now I know the equation that I have. It is ES by EP is equal to NS by NP is equal to IP by IS. Correct? This is the complete equation of a transformer. Now they're saying voltage in the secondary, that is ES, does not depend on voltage of the primary. It definitely depends on voltage of the primary. It definitely depends on the ratio of number of turns. It does not depend on the frequency because I don't have frequency term anywhere. Therefore, answer has to be C, that it does not depend on the frequency of the source. Is it clear? Answer has to be C, that does not depend on the frequency of the source. Okay. Now, question number 5. Try to answer and give me the option. Which option do you think is the right one? Question number 5.
A.
Core of a transformer is made up of soft iron. We have just done it in the diagram itself. Okay. We have just done it in the diagram that core of a transformer is made up of soft iron itself. Core of a transformer is made up of soft iron itself. Correct? Now, question number 6. Start solving and then I'll also do it on the screen. Question number 6. Start.
So now listen. What they're saying, the turn ratio of a transformer is given as 2:3. Now, what is turn ratio? I just showed it to you
NS
sometime
upon
back.
NP.
Okay, NS upon NP is called my turn ratio. Therefore, they have told me that NS upon NP, that my turn ratio of a transformer is nothing but 2:3. Now, if the current through the primary coil is 3 ampere, calculate the suitable current through the load resistance. Current through the load resistance means current in the secondary. Okay. Now, I know that NS by NP is equal to ES by EP is equal to IP by IS. Correct? This is my transformer equation. Therefore, in this case, I will only need NS by NP is equal to IP upon IS. I will only need that relation. NS upon NP is equal to IP upon IS. Now, NS upon NP is 2/3 is equal to 3 upon IS. Correct? Somewhat clear? Now, I have to find IS. So, start and tell me which do you think is the closest option?
C.
Others.
B.
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 Think about it.
It's B.
Answer has to be B. Just check why. Therefore, if you multiply, I will get 2 into IS. Answer, are you getting it as B, everyone? Just check. Transformer ratio is NS by NP, okay? Transformer ratio is NS by NP. Please remember, we have just done it in the notebook also. Okay, everyone clear with this? Now start with question number 7. Start with question number 7. That is the next question itself. Start with question number 7.
So look at question number 7. A step-up transformer is connected to 220-volt AC line. That means EMF of the primary is equal to 220 volt. And it is to supply. Supply means it is to give an output of 22 into 10 power 3 volt. Kilovolt means 22 into 10 power 3 volt for a neon sign in a secondary circuit. In the primary circuit, a fuse wire is connected to which is too low when the current in the secondary circuit exceeds 10 milliampere. The turn ratio of the transformer is now easy. Now I know turn ratio is NS by NP, correct? I have to find turn ratio, NS by NP. But I know NS by NP is same as ES by EP. That is from our transformer derivation. We know that NS by NP is equal to ES by EP. Now, if I want to find ES by EP, what is ES? 22 into 10 power 3 by EP is 220. Correct? Therefore, tell me, what will be our answer? So, can I write 22 into 10 power 3 as 220 into 10 square upon 220? Now, 220 and 220 will cancel. Therefore, NS by NP is 10 square. Now, 10 square is nothing but 100. Therefore, answer for the 7th one will be B, which is 100. Just check if you guys are getting the same answer.
So, sir, what do we do of 10 milliampere?
That is dummy. In the sense, if they ask other things, then you can find out. 10 milliampere is current in the secondary is 10. We can get current in the primary. Then we can get IP by IS is also equal to NS by NP. That also we can do. But there is no need to do that. With NS by NP itself, I can get the answer. That means if I am using NS by NP is equal to ES by EP, then the current becomes a dummy value for me. Means not required. Okay, all of you. Now come to question number 8 and tell me what should be the answer according to you. Question number 8. So question number 8, the ratio of the secondary to the primary turns in a transformer is 3:2. If the power output is capital P, then what will be the input power neglecting all the losses? Neglecting all the losses means it is an ideal transformer. There is no loss, that means it's an ideal transformer. And you know, for an ideal transformer, input power is equal to output power. We just did that derivation sometime back, that for an ideal transformer, input power will be equal to output power. Therefore, in that case, answer will be P itself, because
B.
if the output power is P, input power also will be P. Therefore, answer will be option C. Just check. Option will be C. That is, input power will be equal to output power. Okay. Now,
No,
start
sir,
with,
I did not get it.
we have just done one derivation. Where is that
Yeah,
derivation?
that I know.
1 minute. Check. For an ideal transformer, input power is equal to output power. So if input power is P, output power also has to be P. That is the question. Therefore, option is C. Just
Okay. So even in this 3:2 is a dummy data. You don't use it, right?
you have to find voltage and current, we'll have to use it. Otherwise, for power, we don't have to use it. Or else, if power is not ideal, then we'll have to use it. Otherwise, we don't need to use it.
Okay.
Question number 9. Start. Question number 9. Now, look at the next question. That is question number 9, right? Yeah, that is question number 9. Now listen. A power transformer is used to set up an alternating EMF of 220 volt. That means EMF of a primary was 220 volt to 11 kilovolt. That means 11 into 10 power 3 volt. To transmit, so power in the secondary to transmit is 4.4 into 10 power 3 watt of power. Now, if the primary has 1000 turns, what is the current rating in the secondary? Means what is IS? Assume 100% efficiency of the transformer. Whenever they make such a statement, I'll have to use power formula, 100% efficiency. Now tell me, how do I get IS? Any clue or anyone? I know ES by EP is equal to IP by IS, but IP is not given. Or I know NS by NP is equal to IP by IS, but again, NS and IP, IS, all three are not given. So I know power in the secondary is ES into IS. Power of the secondary is nothing but ES into IS. You know the formula for power, E into I. Now, do I know power of the secondary? Yes. Do I know EMF of the secondary? Yes. Therefore, IS is equal to PS upon ES. Now what is PS? That is power of the secondary. That is 4.4 into 10 power 3 divided by 11 into 10 power 3. Therefore, can I say 10 power 3, 10 power 3 will cancel. 11 ones are, 11 fours are, but it is 4.4, therefore 0.4s are. Therefore, answer will be 0.4 ampere. Therefore, answer will be 0.4 ampere. Is it clear, all of you? So please make a note of this, where answer is 0.4 ampere. Next, page 30, question number 2. Start. Give me the answer and all of you switch on your cam quick. Page 30, question number 2. Start. The magnetic flux linked with the coil in Webers is given by the equation phi equal to 3t square plus 4t plus 9. Find the magnitude of induced EMF at time 2 seconds. Start. Now I know while solving I can use Faraday's law, Lenz's law. Therefore, can I say E is equal to d phi by dt? Actually minus d phi by dt, but I will just take the magnitude. Therefore, can I say d by dt of 3t square plus 4t plus 9? Or can I say E is equal to, what is differentiation of 3t square? 3 as it is. Differentiation of t square is 2t plus differentiation of 4t is 4 plus differentiation of 9 is 0. Therefore, can I say EMF will be 3 into 2,
60.
60 plus 4. Now have the given the value of t? Yes, 2. Therefore it is 6 into 2 plus 4. 12 plus 4. Therefore answer is 16 volt. Therefore which option is that? That is option D. Therefore make a note of this particular problem. Quick. Okay. Now once you're getting this, start with question number 4. Same page number 30, question number 4. Start. Start, sir. Now for question number 4, you have to be very careful because there's only one word which will give you the answer. The question is an infinitely long cylinder is kept parallel to a uniform magnetic field. It is uniform magnetic field. Uniform magnetic field means what? It does not change. Now, if it does not change, that is the meaning of uniform, correct? Now, there is no change in flux if it is uniform. If there is no change in flux, there is no induction of EMF, means EMF is not induced. And if EMF is not induced, then current also is not induced. Therefore, answer will be 0, just because it is uniform. Let me repeat. If it is uniform magnetic field, there is no change of flux. Now, according to Faraday's law, change of flux will lead to EMF and EMF will lead to current. But in this case, change of flux only is not happening. Therefore, answer will be C, 0. Okay. Now, start with question number 7. Same page number 30, question number 7. Page number 30, question number 7. Again, I'll give you the clue. We have used this formula before. Tell me, have we used this formula before? E is equal to BLV
Yeah.
sin theta, or E is equal to only BLV. So make use of this formula and quickly give me the answer for question number 7. Start. So the formula is E is equal to BLV sine theta. Now, so E is equal to, it is saying it is 10 meter, therefore L is 10. Velocity is 5 meter per second. And it is perpendicular, so sine 90 will be 1. And magnetic field is 0.3 into 10 power minus 4. It is 0.3 into 10 power minus 4. So if I do this, 0.3 into 10 will be 3 into 10 power minus 4 into 5. Therefore, answer will be 15 into 10 power minus 4 or 1.5 into 10 power minus 3, or I can say it is 1.5 millivolt, or I can say it is 1.5 millivolt. Getting the answer for 7th one, all of you, as B, correct? Now, using the same logic, try to solve question number 8. Same, page
Can
30.
you show that slide?
Yeah, I will show it. Other people start with question number 8, page 30.
Done, sir.
So start with question number 8, page 30. Using the same formula, question number 8, page 30. So, in a boat moving due east in the region where Earth's magnetic field, that is V is equal to 5 into 10 power minus 5, a boat is length is having 2 meter. If the speed of the boat is 1.5, it is moving north and horizontal means sine theta is anyway 1. Therefore, can I say E is equal to BLV? So E equal to, what is B? 5 into 10 power minus 5 into L into V. Therefore, 5 into 2 will be 10 into 10 power minus 5 into 1.5. Now, 10 into 1.5 is 15 into 10 power minus 5, or 1.5 into 10 power minus 4, or 0.15 into 10 power minus 3, or it is 0.15 milli. This is the answer. Therefore, option will be D. Just check if you're getting this as your option. Option will be D for question number 8, page number 30. Let's check. Okay, understood all of you? Okay. Now start with question number 10. Next page number 31, question number 10. Page number 31, question number 10. Page number 31, question number 10. A metallic square loop ABCD is moving in its own plane with a velocity v, uniform magnetic field perpendicular to its plane. Therefore, electric field will be induced only when the angle is 90. We have done in moving coil galvanometer also. So can I say AB and DC, you will not have anything because it is parallel to the field. Okay, therefore if I have this, it is A, B, C, D. Can I say over here and over here, it is 0 degrees, so nothing will happen. Therefore, the only two sides where I'll get some force, torque or field is AD and CB. That is AD and CB or B into C. Therefore, tell me which option matches these two vertical. Same like moving coil galvanometer. Answer will
But-
be
D.
answer will be D in AD and BC.
Excuse me, sir.
Hmm.
Sir, AD and BC are also parallel to each other, no?
No, there is a field. AD and BC are parallel to each other. We are not saying parallel to each other. They have to be parallel. They have to be perpendicular to the field. Parallel to each other, it is perfect because anything that is perpendicular to the field will be parallel to each other. Okay? You have to
Okay.
compare it with the field. This is the field. Now over there, AB is with the field. Therefore, no angle, 0, force 0. Over here, no angle, 0. Over here, maximum. Over here, maximum. They have to be parallel to each other. In fact, when we did moving coil galvanometer, what was the formula for torque? Magnitude of one of the forces into perpendicular distance between two parallel forces. Okay? Between them, they are parallel, but with the field, they are perpendicular. Therefore, answer will be both AD and BC. Okay. Now, question number 11, take it as your homework 1. Question number 11, take it as your homework 1. Question number 11, take it as your homework 1. It is a very simple concept. It is BLV in relative motion. If they're going in opposite, tell me what will happen. That is your homework. It is oral question. It is not something you have to solve. Next question that you have to do right now is question number 17. We have done it in our theory part. So tell me, what do you think should be the option for question number 17? Let's check and let me know.
D.
C.
What is the maximum EMF generated in an AC generator? What is the formula? Answer is C. We have just done that right now. That maximum EMF in an AC generator is NAB omega. Just check. We have done that right now. It is NAB omega. Okay. Question number 19 is your homework 2 on the next page. Question number 19 is your homework 2 on the next page. Question number 20 is your homework 3. Question number 20 is your homework 3. Question number 31 on next page, page 33, start solving. Question number 31 on the next page. That is page number 33. Page number 33. Question number 31. Start. It should be a direct question. Start solving. (31). Give me the answer for question number 31.
Option B.
Correct. Option B will be the answer for question number 31. Others try to answer. Answer will be 2 ampere. That is option B. Just check if everyone is getting it. It is a direct substitution of our formula. Okay. Question number 31. Answer is B. 2 ampere. Now, question number 34. Same formula. E is equal to BLV. Quickly give me the answer. Question number 34. E is equal to BLV. Start with that formula and tell me whether you're getting the answer for this. Start. Question number 34.
Option C. C.
Answer should come as C itself. Just check if everyone is getting it. Answer should come as C.
Yes, sir. C.
Are you getting it, all of you? E is equal to BLV. E is equal to BLV. Getting it, all of you? In that L is 2 centimeter, which is actually 2 into 10 power minus 2 meters. So let us start. E is equal to BLV. Length is 2 centimeter. 2 centimeter means 2 into 10 power minus 2 meter. And the speed is 6 meter per second. Speed is 6 meter per second. And uniform magnetic field is 0.1 Tesla. Therefore, what is the potential difference? E. Now, so E is equal to 6 into 2 will be 12. 0.1 can be written as 10 power minus 1 into 10 power minus 2. What did I do? I did 6 into 2, which I got the answer as 12. 0.1 I wrote it as 10 power minus 1. Therefore, E is equal to 12 into 10 power minus 3, or it is 12 millivolt. Therefore, EMF is equal to 12 millivolt. Getting it, all of you? Clear? Okay. Now, we'll continue tomorrow morning at 7 to 9 again. Okay, tomorrow, 7 to 9. So for today, we'll stop it here. We will continue tomorrow. And tomorrow we'll go to the next topic also, which is AC circuits. Okay. So thank you, everyone. I'll see you tomorrow.
Bye.